Hello guys, welcome to another episode on Chuks. The last episode we looked at how to install and set up Chuks, but in this episode we are going to be looking at Chuks variable and Chuks variable type declaration. We're going to see how you can use Chuks variable, how Chuks variable work, and how it's being used in our everyday today programming. Without further ado, let's continue. So on my screen, I'm currently on the Chuks website. So you can go to the Chuks website by entering the URL in your browser, chuks.org. That is chuks.org. Now on the Chuks page, if you want to get to the documentation, you're going to click on the Get Started um, link. Now on the Get Started button, it takes you to the documentation page. And on the documentation page, if you scroll down to Language Guide, on language guide, you're going to see variables and type. So this is what we are going to be looking at. So you're going to be looking at variable, we're going to be looking at data type. We're going to start with the variable and constants. You can see here, Chuks has the expected ways of handling variables. I think it uses var, uses const, and you have const max size, and you can actually explicitly declare variables, including their type. And you have also the basic variable type. You have the default values. And I think, yes, this is talking about class, and now you can actually declare variables in a class. And yeah, we're going to look at all these things in um, today's episode. So without further ado, let's get to our terminal and let's see how this works. So on my screen, I have my VS Code open, and on my VS Code, I have created a new file called variable.chuks. The variable.chuks file is going to be used for the demonstration of chuks variables. Now, in the variable.chuks file, I have two lines of codes. Now, in the first line of code, you would see that I am declaring a variable called name and also declaring a variable called pi. Now, what does this mean? In the choose slang, there are two types of variable declaration. You have the first variable, which is um, mutable, meaning that you can edit the variable during runtime. Variable cannot, whatsoever values in the variable can be overwritten at any time during the runtime. Then you have the second type of variable, which is the const variable, um, which is immutable. Now, this const variable, it means that once you've assigned a value to this variable, the value cannot change within your runtime. So it's constant, hence the name constant. So these two types of variable are actually called immutable variable and immutable variable. Now we can demonstrate that by doing this. So for example, for the mutable variable, we are going to do something. We're going to say print ln, and we're going to display the content of the mutable variable and the immutable variable. So we're going to say name, and we are going to have another print ln, and we're going to say pi, right? So let's see what the output of this is going to be. So we're going to do this by running chuks run variable dot chuks. Good. You see the output. The output of name is Alice, and the output of 3 points of pi is 3.141. Now, what's the difference between the mutable variable and the immutable variable? Like I explained before, one can be overwritten during runtime, the other one remains constant during runtime. So let's see that. How does that work? Delete this. So for that, we are going to actually change the name of Alice in our runtime, and let's see how it's going to happen. So I can come here and I can say name is equal to Bob. Let's see if it changes when we run this program again. So I'm going to come here and I'm going to say run Chuks. Exactly. You can see that here Chuks was changed to what? To Bob. How about if we change PI to something else? So we come here, we say PI, that is pi, is equals to 4.0, what happens? So we come here, we clear, and we say run Chuks, and you can see it throws an error. Why does it throws an error? It says cannot assign to pi because it is a constant. So the constant variable type is immutable, and the var variable type is called um, mutable because it can be edited during runtime. So now that we know the types of variable, which is the mutable and the immutable constant, let's look at the types of variable that we can have, variable typing. Now, Chuks presents to us different types of variable types, right? Variable typings. We have the int, we have the string, um, we have float and the rest. So we're going to be looking at that. Now, on my screen, still on the variable.chuks file. Initially, you see we have two variable. One is name and one is pi. The name is like mutable, but the pi is immutable. So what we want to see is, if you look at this, you will find out that we actually not typing this variable. We've not explicitly declared their types, right? And if you look at these comments I have here, one says mutable variable with type inference, immutable variable, immutable constant with type inference. Now there is something I want you to know about Chuks. Chuks is strongly typed, right? What this means is that every variable that is declared has to be typed in Chuks. The Chuks compiler wants it to be typed. Now, for example, in this our use case, we did not explicitly declare the type of the variables, and Chuks has the capability during its compilation or its compile time or during its runtime to infer the type of the variable based on the value that is being passed into the variable. So if you look at my screen here, you see that here I did not type it explicitly, but I actually passed in a string. So when Chuks is compiling this, Chuks is going to assume that, okay, um, this is a name variable, right? The value of this variable is actually a string, and the user did not declare the type. So um, I'm going to assign the type of a string to this variable. That is what Chuck does during the runtime and the compile time, right? It looks at it to say, okay, the type was not explicitly defined, but what value is it holding? Is it a string? If it's a string, the Chuck's engine is going to actually infer that type against the variable. Same thing happens for the PI constant. It looks at it and says, okay, what is it holding? Or it's holding a float, right? Um, the user did not explicitly define the type. So based on this float it is holding, I'm going to infer the type of float to this variable. So this is what Chuks does under the hood in terms of um, type inference based on the value you pass it. But now, if we want to write the clean way, I think it's good that you should kind of type your variable, especially when you're dealing with APIs and the rest. You want to create strict API adherence and structure. What you want to do is you want to ensure that your values are, or variables are always typed. Now, in that case, what um, how do we go about variable typing in Chuks? It's very simple. Let's do that. So to declare an explicit type on a mutable variable, all you need to do is to say variable, the name of the variable name, then you have your colon, then in front of it, you pass in the type. When you pass in the type, you can now assign the value. So to say, in this case, you're going to say Alice, all right? If you want to do that for an immutable constant, you do the same thing. You say const, right? Um, time, I'll use time. I want to declare this as float, or let's use pi, not time. Pi. I declare this as float, right? It's a float point variable, and I'm going to define it as 3.14132. Now, this is how you declare an explicitly typed variable. So we're going to see the result of this variable by printing their value out. Print ln, and we're going to say, I'm going to use string interpolation here to say, I'm going to say name, yes, name, and I think it takes the $sign. Please pardon me, name. I'll use the pipe, and I'm going to call this, yes, I'm going to pi. So when we run this, we should see the variable names without error. So we'll run this, and here you can see we don't have an error. So what happens when we declare a variable and explicitly type that variable, and for some reason we then pass the wrong value? I think we can only test that using the name variable. To achieve that, we're going to say, let's assume there's an error within the code. Say name is equals to 20. What happens when I save this? Right? I think Chuks should scream at me upon seeing this. Exactly. It says type mismatch is assigned. Exact string got int. So it's complaining of this line 4, meaning that it's strictly typed. Once you've typed a variable, you can't go back. Yeah, so that's it. So what if we don't even type the variable to test the type inference, and here we pass in a string, and here we're coming to use 20. Let's see how Chuks is going to behave in this use case. So we're going to run Chuks again, and we're going to say this. We still get the same error. It said type mismatch. You assign string here, right? And you're coming here to assign an integer. So even the inferential typing, right, still ensures that you stick to what you initially, the initial type of the variable upon the variable declaration, which I think it's a very good one. Now that we understand Chuks variable and their types, let's look at the common types of variables we use 90% of the times in our day-to-day programming. So if you look at my screen, I've declared about 4 variable and nothing special. We can see that it's here Chuks enables you to declare variable as integer. Chuks enables you to declare variable as float. You can declare a variable as boolean, which accepts true or false, and you can declare a variable as a string, right? Now let's see how these variables will come out if we do a print ln and we do string interpolation, and we'll say integer equals count. Yeah, let's just call this counts, not integer. Then we pipe this and we say next variable is price, and we do this price. Next variable is active. We do this again, and the next variable is letter, and we do this again. So how would Chuks present all this? When we do Chuks run, I think it should give us exactly what we're looking for. So our count is 42, our price is 9.99. We have active to be a boolean of true, and we have our letter to be Z. So these are most variables you're going to be using in Chuks. You're going to be using the int, you're going to be using the float, you're going to be using the boolean, you're going to be using the string. So Chuks supports your standard out of the box types for your regular day-to-day programming. I also want to mention that Chuks also supports union types. Take for example, we have var count is equals to 2, right? Now, if we want to make this strictly typed or explicitly typed, we'll say this is int, right? And here we say print ln, and we say count. So we wanted to print the count. If we come here, we run Chuks, you can see we have to. Now, Chuks also supports union type such that we can also make this a string. Now, this is a union type. So it means that right now, we can assign a string to the count variable without having errors. So if we assign a string to the count variable and we do the print count, let's see what Chuks is going to see on the terminal when we run it. You can see, so it's changed from an integer to what? A string. So that's a very fantastic thing about Chuks union type for those of you coming from TypeScript. For those of us coming from languages where performance precision is not debatable, Chuks also supports some very basic data types that might be very valuable to you. For example, if you can see on my screen, we have various categories of Chuks type. And here for the integer type, you can see Chuks supports your int 8, int 16, int 32, which gives you very, very precise memory allocation rather than just giving you the default integer memory allocation. If you really, really need to squeeze out that performance precision um, from your system or your machine, right? It also supports signed and unsigned integers. For float, you can see we have floats and floats 32, floats 64. Whatsoever data type you need, Chuks can also provide those data type for you for performance precision and memory management. We also have the null type, we have the dynamic type, which is any for those of us coming from JavaScript and TypeScript. I think we'll be very familiar with any. We have the Boolean string void also out of the box. So Chuks data type packs a whole lot of data types that can enable you to build your application however you want it, putting performance and memory management consideration into mind. I also want to mention that you can call some particular methods on Chuks variables, especially based on the type given to that variable. For example, if you look at my screen, I have a variable called count and it's of the type string and it's assigned to. I can call some particular methods on this, for example, like length, which we popularly know, that counts the length of the string. So if I save this and I go to Chuks and I run, you can see it's 3. What happens if I add another value, another character to this? Let's see what happens. I save this, if I run it, it decreases to 4. So we have some other popular functions that we call on variables like this. So for example, the popular one is to uppercase. Uppercase. I want to believe I'm spelling this well. So if I save this and I run, I get TWOD capital case. What if I do to lower case and I run again? You can see it allows to lower case. So Chuks have methods that you can call on variables based on the type that is assigned to that variables, which we just checked out here.